Hello, how's everybody doing today? Today we're going to talk about uh, imaginary, theoretical, and factual data. Uh, Theoretical data really stems from the imagination. Everybody has a theory and they imagine it to be a certain way, and then it develops into a theory. And then through the theoretical process, you start applying uh, data and hard facts in order to support that theory. So, in my theory, and it's just a theory, I'm trying to establish some hard data into that theory to give it more weight that uh, possibly it could help in locating uh, the theoretical treasure that is on Oak Island. So therefore, I like to stay within the known data set that we already know. I don't like to make up imaginary um, data if I don't have to. Sometimes you can't help it because you have to start from somewhere. So you have to take a stab in the dark and imagine that this rock or this post or whatever it is going to become integral into the theory, have a connection. So let's start off here with uh, some of the hard data that we have that we know. If you look at this, these black lines are all on Fred Nolan's map, and they are connected to known data points that Fred Nolan has made, or they're connected to a landmark that is already established on Oak Island. For instance, let's start here. Down in this area, we have the line, this black line going right here is of course the bottom pointer section of Nolan's cross. Just since I'm here, I'll tell you this blue, light blue, indicates a calculated marker, and this is the X point on the pointer between the last two rocks on Nolan's cross. These blue lines right here are theoretical. So anything you see in blue is a theoretical line. Anything that you see in red is in between theoretical and hard fact. And I'll tell you how it works. The red ones emanate a vector from a known, already known hard landmark, where the black run, their vectors run through at least two known landmarks. So that's how you can tell what's happening on this map. So if we go up here where there's a big convergence of black landmark or vectors, it's right here, and this is a point that Fred Nolan, and I believe it's a drilled rock because it was on one of his other maps. It's actually located down here on his other map, but his other map was a novelty map, so it was on the same line. And just a little fact that this angle right here that comes off of the headstone to this drilled rock is the same angle as this theoretical blue line right here, this large one that goes from corner to corner on these things. It's roughly around 26.5 degrees. So we have the end of Nolan's cross right here, and there's a stone there, and this line runs to that stone directly due north, and there's a stone here. You can, or a landmark that Fred has done. Probably it's a stone. He doesn't have it marked, but this runs from. He did not measure this here, but if you take a vector through the headstone to this drilled rock, it bisects it perfectly. One of the things in this theory is this white triangle here goes from the ends of Nolan's cross to the second stone in the pointer right here. And if you flip that over across the crossbars and extend this out here, the exact same distance, I believe it's 430 feet, you end up right here. Now I have this triangle in black, but it should be possibly red. But there is a connection between this point and this point, which makes this section black, but this section would still be red, and this would be totally red. Even though there's an intersection point here, we're not quite sure, but my theory is that this is extended out to here, and this right here, if we pull up Zena Halpern's overlay, let's see if we get this right. Yeah. This is where the second anchor is. We got one anchor here. We got another anchor here. And these are, the anchor stones. Whether they're stones, I don't know. I've always called them stone, that they were going to be stones at the beginning. But that is the way I have this placed. One of the things about this map is there, and this is pretty much accurately placed. If you want to see, it's pretty much accurately placed. It's different than the shape of the island, so, but if you look at some of these other markers, like the second triangle is right there. I mean, it's right where it's supposed to be on the map. So if you take a line, and this theoretical line, remember blue is theoretical, if you take a line through that and take it to the original stone triangle placement, this right here is where Fred Nolan did an adjustment to the original stone triangle. But if you take it to the original stone triangle, it goes through the anchor point here, and that is pretty amazing. The other thing is this is theoretical too, from the midpoint here through the anchor to the triangle of Peter. Now we have a line, a red line, coming from the triangle of Peter because it emanates from the top of the stone. But it also goes through, or at least at a vertex, or intersects a black line. So I gave this one a red because it's in between. If we were to find the stone triangle and verify that, then it would become black, and that would really become a very important convergence point. Anytime you have a convergence point of two lines, two black lines, then you're getting to a point of where it's becoming a factual point. For instance, the northern anchor. Alright, let me turn off Zena's map so we can see. In the northern anchor, we have two convergence lines. We have the vector coming from these two stone piles, and we have the vector of Nolan's cross, which is a true black vector that comes all the way out, and they both converge here. That's why I believe that this extension of this triangle is valid as black, the whole thing, because I believe that's what is intended to do with Nolan's triangle. And this is the anchor stone, and once you get this point right here established, okay, then we have a east-west line, a completely due east-west line. And the thing that's good about this one, this is theoretical, because it doesn't really come off of any known point yet, but it bisects these two stones right here. It bisects it. And another bisection is right here. This bisection right here goes through these. And this is a black line because it lines up perfectly with these stone piles. And it also terminates at this point, which is what I call the west vertex, which is where you go through the headstone all the way through, and Fred Nolan had it marked. It's right here. And this lines up also with these two stones. So you got somebody with a fire on this stone, somebody with holding up a pole on this stone, and you sight in this line, and then you have somebody standing here with this on this stone and somebody standing on here with this stone, and you line them both up, and you're now sitting on the center line in perfect angle. Now that's just speculation, but the lines that these stones create are real. So we have it going through these. There's another stone right here, but I think it is for this line, and this line goes out to here. Now the fact that it goes out that far, or goes this way, doesn't mean that it terminates at this corner, because that would be theoretical. It could go out all the way to what it would be just south of France and south of Jerusalem, right? So it's theoretical. If this point right here and this point, if this was black and a known point, and this one was black and a known point, in other words, let's say we change the rules and say if this line terminates at a black intersection and this one terminates at a black intersection, and it's going due east-west, which would be somewhat common in this theory, then it could be black. If this is black, then this point becomes very important. So let's apply that rule with this one. Okay, this blue line, theoretical blue line, intersects a black line. It also intersects a vertex of two black lines. Okay? But it terminates at a theoretical point. However, that theoretical point has a lot of vertices, and it also has one red vertice. That means it's going through at least one of the known points at Nolan's cross, and it's right here. Okay, so that's a known point, but that can spin 360 degrees, so that doesn't matter. But this right here is pretty important, even though it's not a point on the map or known, but it is an intersection of two black lines. And it's emanating from a vertex of two black lines. Remember, these black lines are hard vectors from known objects on Oak Island. They are known objects. So if we were going to change those rules, then this theoretical line here at the top becomes black. This north-south line becomes black. This east-west line would become black. Pretty much all these would just end up being black. All these theoretical lines would become black. And except for this red one right here that emanates from here, well, actually that one would too become black. So I guess what I'm saying is there's a level of theory, there's a level of fact, and there's also this is emanating from the beginning through an imagination of what is happening, which I derived from the Zena Halpern map, the Le Formula, and this is how I arrived at this theory. So it's looking like, and the other theory I have is the 45-522, which when you take the interpretation of the French interpretation of the Le Formula, it says from don't dig 40 feet, and then I say it says, it's a period right there, it says go 45 degrees for 522 feet. That's on the surface of the earth, and you will find the shaft. And when you find the shaft, from there you will go 1,065 feet, which is, and I don't have it up there now, to the vault under the earth. Let's see if I can find that. I got so many things on here. It's hard for me to find it. Vault under the earth. Here it is. It goes from here to here. And if you look at the properties, the length measurements in feet is 1,065 feet. So that's my theory, and it is not based completely on imagination. It is based on hard data and somewhat reasonable theory. Thanks for watching.